Today, I'm going to discuss the scientific method. If you've taken a science class before, you've probably heard about the scientific method. You may remember that it's the process that is used by scientists when they want to prove an idea. Maybe you've participated in a science fair wherein you had to show how you used the scientific method to prove a hypothesis. But I'll bet you've used the scientific method a lot more than you even realize. Everyone uses the scientific method all of the time when they're trying to figure out how something works. It's a much more effective way of learning than having a teacher say, "This is the way things work." Let's get something straight. Babies are stupid. Yep, I said it. The fact of the matter is that babies really only know how to do 4 things. They sleep. Cute, right? And they know how to suck. Still cute. They poop a lot. And now we're getting a lot less cute. And they sure know how to cry and cry and cry. This is not cute. That's really about the only things that a baby knows how to do. Babies have been called a blank slate because they need to learn everything that they're going to need to know. So, how do babies go from being a blank slate to being smart, or really really smart? How do they start to understand and think on their own? How do they go from not understanding that things will fall down instead of up or sideways to being able to design and build complex machines? Well, they've got to learn it. But how do they learn? We can't teach them by talking to them because they don't understand language. Still, babies figure things out. They start by watching things. Everything is brand new to them, so they watch and watch. Not just people either. They watch everything. And then they start to get ideas about how to do things, so they try out their ideas. And they're usually not right the first time, or even the second time, or the third time. Now, I don't even know if these kids are trying to figure out how to get a drink, or use a hose, or a phone, or what. But eventually they do figure it out. Oh, it was the phone. Now, before you know it, the kids are wicked smart. Scientists have taken this process that every single one of us have used since birth and have done what scientists do best. Give it a really boring name. It's called the scientific method. The scientific method has 4 basic parts. First, we make observations and collect data that leads to a question that we want to test. This is called a hypothesis. Or, if you have more than one question or idea, they're hypotheses. Next, we figure out a way to test the hypotheses in ways that will either prove or disprove them. Really, the best experiments will try very hard to disprove a hypothesis. Once we test our hypothesis, we need to look at the data from the test and see if it lines up with the hypothesis. If not, we need to change our hypothesis and test all over again. Finally, we need to let others know what we've come up with. That way they can evaluate our data and results and see if they agree or can come up with an alternative hypothesis. Now this can come in many forms, from showing someone what we've learned, "Hey, I can talk on the phone," to submitting a paper to a scientific journal for review by other scientists. Here's an example of my daughter testing hypotheses about how to fit wooden blocks into holes. She's seen me put the blocks into holes before, and she's also experimented with taking all of our utensils out of the drawers in the kitchen and sometimes putting them back in. She has an idea about how to put the block in, but when that doesn't work, she has to try a slightly different idea or hypothesis. And eventually she gives up. You guys should not give up. Here's an example from the world of physics. By 1911, we had figured out that atoms were made up of positive and negative parts. The theory at the time was that atoms were structured like plum pudding. Most of the material was pudding, which had a positive charge in the model. However, there were negative objects, electrons, that were like chunks of plums floating around. If you haven't had plum pudding in a while, you could also think of it like chocolate chip ice cream. The positive part would be the ice cream, and the negative part is the chocolate chips. A man named Ernest Rutherford set up an experiment to test if that model was correct. He decided to shoot an X-ray through a thin piece of gold and surrounded it with a screen. If the plum pudding model was correct, the X-rays would pretty much go straight through the plum pudding and light up the screen behind the gold film. And mostly that's what happened. But he also observed that some particles would bounce off the gold at different angles, which didn't agree with the model. So he had to come up with a new model. Rutherford's model showed the atom as mostly empty space. There was a hard nucleus in the middle with tiny electrons flying around it, somewhat like how planets go around the sun. This model would allow most X-rays to pass right through the atoms and light up the screen behind the foil. But he also said that occasionally the X-ray would collide with the nucleus and bounce right back off. Boom. Rutherford made observations of the existing model of atoms, as well as data about the different parts of an atom. This was the first step in the scientific method, and it led him to create an experiment to see if that model was accurate. The second step of the scientific method. The third step occurred when he realized the results of experiments were not consistent with the existing model, so he had to change his idea about the structure of the atom. Finally, he published his results and his new model for other scientists and engineers to observe, test, and modify on their own. Whether for children, scientists, students, or in everyday life, the scientific method remains our first and best way of learning facts about the world around us. Thank you for your time and attention.